Okay, so basically this is my program that I'm going to teach you about queues. Okay, now we are going to implement these queues using linked list. So as you know, linked list is a collection of nodes, and a node is having a structure wherein a node is made up of two parts, a data part and a next pointer. The next pointer points to another node. Okay, so collection of nodes which are linked to each other is what is a linked list in simple words. So there are different types of linked list which we will see later. Okay, so today we are going to implement queues using a singly linked list. And what is the characteristic of a singly linked list? Can you tell me? How do you know just looking at a diagram of a linked list whether it's a singly linked list? Can someone unmute and tell or type in the chat? How do you know it's a singly linked list just by looking at the diagram?
Last node is null.
The last node.
The last node
node
is
is null.
yes. Please be careful when you are saying this. Okay, so again Prajwal also see last node will not have null value. That is wrong if you say like that. So if I was conducting an interview and if you would give me this answer, I would not consider this as the correct answer. The next part of the last node will have null value. Okay, you have to say it correctly. If you just say last node will have null value, that's not correct. The last node's next part, yeah, Samiksha has written it. So last node's next part has null. So that should be the proper answer. Okay. So I know you all mean the same thing, but please be careful. Okay. So just for the sake of the diploma students, I'll just tell. Okay. So suppose you are having a node is nothing but something like this, what I've highlighted. Okay. So node will be having two parts. So for example, this will be the data part, what I just made yellow, and the other part will be the link part, what I made green. So node is having two parts. Okay. And the node will be having some memory address. So I've just made something like 700 here. It will be having some hexadecimal value, a big number, but I've just taken a small number here for you to understand. Okay. So remember, a node will be something like this. So in programming terms, when you declare a node, you declare a node like this. Okay, you declare a node like this. So like I told you, it will have two parts, a data part and a pointer part. So that pointer part will be something like this. This will be a pointer to a node of itself. Okay, so this is a variable of that same type of structure that you have declared for the node. This is known as self-referential structure. The structure is referring to itself. You are declaring a variable of itself as a member. So it will have two parts, a data part and a node part. So if you are, yesterday I had asked you all to watch the linked list videos. In case you all have watched, then you will know this what I am referring to. Okay. In case you have not watched, then please do watch. Then here, as you can see, as we have discussed before now at the beginning of this lecture also, a queue will be having two pointers, front and rear. So in this case, we are implementing a queue using linked list. Since the linked list as of now does not exist, we have not created any nodes. We set both these values of front and rear, both the pointers values are set equal to null. Okay. So since again, please note it down. Okay, what is being told? You should have your notebook open with you, and you should be noting down what is being told. So this is what is why that is why we are having the value equal to null. If someone asks you why you set this value equal to null, right now you should be able to answer. You have not created any nodes as of now, so that's why these values are initially set equal to null. Okay. Then I've declared this function prototypes. So these functions are defined later after the main functions. So we are having these two operations, NQ and DQ operations, that we can perform on the queue, and this third function is to display all the values that will be there present in the queue. Okay. So function execution always, your program execution always begins with the main function. So basically this is where your execution will begin. So all your, like you can see here, these are the messages that will be displayed. I've declared some temporary variables, choice and value. Then I'll display this message. and then your entire program is getting executed within this while loop. Okay, so basically I'll be displaying something known as a menu. So I'll be displaying a menu, meaning I'll be displaying some choice. So like for example, here you can see in this statement here, I'm displaying choice that one will be insert, two will be delete, three will be display, and four will be exit. So I will ask the user to enter one of those four numbers. Okay. So depending on what number has been entered, the appropriate action will be taken. So suppose by mistake the user enters the wrong number, then we'll be printing this message that wrong selection and try again. So basically whatever choice has been entered will be fed as an input to the switch case, your switch statement. And then inside the switch statement, we are having various cases corresponding to those choices that we have given. So one will be doing the insert case one, case two will be doing the delete, third case will be for displaying, and fourth case is to terminate the program. And then we have the default case by mistake if the user has entered the wrong number. So then we will ask the user to try again. Okay. This while loop runs infinitely. Okay. So that's why we have put here value one. Value one means the condition is always true. Okay. So this while loop will be running infinitely. So every time it will keep displaying the menu. And you can only terminate your program when you enter the value as 4. So that is why we have put here value 1. So I'll show you how this while loop runs. This is what is the meaning of the menu. Okay. So basically this is what will happen. Your choice gets displayed like this. Okay. So this is what will happen. Okay, students, I think I got disconnected. So, what was the last part I was explaining to you all? Was I explaining this menu part?
Yes, sir.
Okay. Did I run the program and show you? Have you seen that part where I ran the program and showed you?
So you were showing the menu part of it. Yeah.
Did I run it in Visual Studio and show you that part you all have seen?
I'm not sure, sir.
Okay, okay. I'll just continue then again. Okay.
Yeah.
So basically, I was telling you about this menu part. So what I was telling you about this menu part is these are the statements that will display a menu. So basically, you will have 4 choices that will be displayed according to this printf statement. Okay. So 1 will be insert, 2 will be delete, 3 will be display, and 4 will be exit. And then the user is supposed to enter one of these 4 choices. Okay. So whatever choice has been entered, the number that will be given as input to this switch statement. Okay. So if he enters 1, the user enters once, you will be operating, you will be doing the case 1. So case 1 will be your enqueue or your insert. Case 2 will be for delete. Case 3 will be for display. And case 4 will be for terminating the program. Suppose the user by mistake enters a wrong choice, then there's a default case which will be asking the user to enter the value again, try again. Okay. And then we run this menu infinitely. So that's why inside this while statement, I put the value here as 1. 1 means this thing is, condition is always true for the while statement. So it is true till we terminate the program. Okay. So this condition will be true till we terminate. So the termination takes place here using this inbuilt function exit. Okay. So that is the time we will directly exit or terminate our program. So that is the time this will be exited. Otherwise, till then this will be an infinite loop. Basically, if I run this program and show you, this is the way it will look for it. Okay. So the menu will be displayed like this. So you will have insert, delete, display, and exit, and you will be asked to enter your choice. It's the same like here, these statements here. Basically, these are the lines that are getting printed. They have just highlighted. So when they get printed, it will look like this. Okay? You can just compare and see. This is the way it will look. Okay. So I'll run this program later and show you. First, I'll explain it for you. So let's assume that we are entering first the choice as 1. Okay. So when I enter the choice as 1, I will enter this case 1. When I enter case 1, I will enter some value to be inserted into the queue. Okay. So I, for example, have taken this value 20 to be inserted into the queue. So let's assume that the user has entered the value as 20. Then I call the insert function and I pass that value to be inserted. Okay. So that is passed as a parameter. So when I call this function, control is transferred to the insert function. This is your insert function. Okay. So before you, like I told you, if you remember, initially the queue I had set value of front and rear equal to null. So here I had set the value of front and rear equal to null. And I also told you why it was set equal to null. It was set equal to null because as of now we do not have any queue with us. Okay. So I just written that here. This was the initial condition. Okay. Then I've called the insert. So inside the insert, now I'm going to use this temporary variable of this type struct node to create nodes. Okay. So this is the local variable. So it will create nodes of this structure having 2 parts, data part and a next part. So the first step of yours will be to allocate memory for that node. So you're going to allocate memory for the node using this malloc function. So memory will be allocated of this size and of this type, and it will be pointed by the variable of called new node. So basically in diagram form, this line will look something like this. Okay. This line will look something like this, what I've just highlighted. a node will be created, okay, with some memory address. So in this case, I've said memory address is 700. It could be any hexadecimal number, okay. And since we are telling that whatever memory will be allocated here will be pointed by this variable, that's why in this diagram here we are having this variable pointing to this memory. So this is nothing but a node having two parts. This is the data part, okay. This is the data part, what I just made in yellow, and the other part is the pointer for the another node. If in future we are going to create more nodes, this green part will be pointing to the other nodes, okay. Okay, so this is what will happen in the first line of your this program. So memory will be allocated for the node. In the second line, I wanted to insert, I passed the value 20, so I want to insert that value 20 in the node. So I will insert that value in the data part. So how I access the data part? I access it using like this. So I will say new node, this is the variable name, arrow data. This part is known as data. So I will say new node arrow data. When I say new node arrow data means I am referring to this part. And there I will be putting the value 20. Okay. This variable 20 will be entered there. Okay. So this variable will be having the value 20 and that will be stored in the node at the data part. So when you execute the second statement, it will look, your diagram will look like this. Node will be having 20 in the data part. Okay. Next line, what we do? We make the next part of that node equal to null. So in diagram form, it will look like this. Next part, new node arrow next means this part. That part I make value equal to null. Okay, so that means here null will come. So if you compare with the previous diagram, you can see this was empty, but because of this line here, now here null is come. Okay. Next you go, you check for this condition. If front equal to null, check the value of front. What is value of front? Value of front is null. So this condition is true. So if this condition is true, what would you do? You would assign the value of new node to the variables rear and front. So when you assign the values to that, it will look something like this. What is the value of new node? Value of new node is 700. Okay, value of new node is 700. That you are assigning to the variables front and rear. So that means initially this values of front and rear was null. Now they will get this value 700. So new node, front and rear all will start pointing to the node with the address 700. Okay. If part is executed, then I do not execute the else part. So I will go to this line and I will say insertion is a success, and then I will exit the function. So when I exit the function, this variable will be lost. So only variables that will remain in your linked list will be front and rear. Okay, so it will look something like this. So you will have the value that is deleted, inserted in a node, and when you exit the function, the local variable that is new node will be deleted automatically when you exit the function, and the variables front and rear will remain. Okay, so I will just keep this NQ20 and I'll just scroll down slowly. If you have not understood any of these lines, you can just let me know now itself. Okay.
So can you just explain the last part again?
Which is the last part? This part?
Yeah, yes, sir.
Yes. So for that part, what we are doing is, like I told you at the beginning, whenever we do the insertion, okay, whenever we do insertion in a queue, front has to be pointing to the first element and rear has to be pointing to the last element. Okay. Now in our this queue at present we are having just one node. Okay. Since we are having one node, we need front also variable pointing to this node because it's the first node, and we need rear variable also pointing to this node because it's the last element. Okay. So in order to do that, we check for this condition if front is equal to null. So when you check for this condition, since initially we had made these values equal to null, okay, this condition will be true. Front will be equal to null. So this condition will be true. Since this condition is true, what I do? I assign the value of new node. What is the value of new node? Okay, value of new node is 700. So I assign the value of new node, which is the address of this node, to these variables front and rear. So when I assign the value of this to these variables front and rear, in diagram form it will happen like this. So that means front and rear also will point to the node with the address 700. So it will look like this because of this programming line. Okay, clear? So now this part, can you tell me who was this? Who was asking this question about it? Last part just now.
So me, Siddesh.
Okay, yeah, Siddesh. I think if you had watched this yesterday, I told you to watch this. Have you watched the linked list videos?
So I'd watched a different one, but not yours.
Okay, because I have explained all this in that. I have explained all these things in that. So you will need to watch that part again. Okay. So you just go through that video. That's why I put that specifically request yesterday to you all to watch those videos. So in that I have explained you what is the, suppose if this is the variable, what is the value of this variable at that diagram, how this you do programming for this part, how you do programming for the next part, how you, so all that has been explained in that. So right now it's not possible for me to tell you that again. Okay, maybe at the end of the lecture I can explain you, so you can just keep your, suppose you are not understanding something, just hold it and I'll try to explain you at the end of the lecture. Okay. So any other doubts? Okay, so I'll just run this and show you then what actually happens. So when you run this, I will enter the choice say as 1. It will ask me the value to be inserted. I will enter the value as 20. Okay, and then it will display me the value here as insertion is a success. So basically this is what has happened there. These all steps that I have just explained to you has happened there. Okay, the node has got created. After the node has got created, we are having this front and rear pointing to the first node. Why it is pointing to the first node? Because that node is the first element in the queue and also it is the last element in the queue. That's why we are having this, we are checking for that and then we are assigning the values. Okay, so in the diagram form it will happen something like this. Clear? So when I exit this function now, when I exit this function, okay, this variable new node will get deleted. Okay, why? Because it's a local variable. So local variables, the scope of local variables does not exist after the end of the function. And why front and rear will remain? Because front and rear are global variables. Okay, so these variables will remain. They do not get deleted. So they will remain in your linked list or your queue, whereas new node will get deleted. Okay, clear? So as you can see here, after inserting, again the menu is getting displayed. So again when the menu gets displayed, again say suppose I want to enqueue, so I will put the choice as 1. So when I put the choice as 1, again it will ask me what value I want to insert. So I'll take the same value that I've taken in my example here. Say I want to insert a value as 78. So when I say I want to insert a value as 78, so if I press enter now, it will insert the value. So I'll explain you this process again, how this 78 will get inserted. So now, as you can see here, there will be two values. Okay, there will be two values in my queue. So can you just type in the chat where will be the front? Will front be there 20 or it will be there 78? And where will be the rear, at 20 or 78? After the insertion of the second element, what will be the value of front? Where will be front, at 20 or 78? What will be the position of rear, at 20 or 78? Can you type in the chat, all of you? Correct. So all those who have typed, yes, correct. So front will be at 20 and rear will be at 78. Correct. Okay. So now this is what has to happen. So I'll show you how it happens. Okay. So now in our queue, we are already having one element. Okay. So this is that element that we are already having. Okay. So this is that. Okay. In that, ignore that second node. So this is what we are already having, what I've just highlighted. So front is pointing to this because it's the first element, and rear is pointing also to this node because it is the last element. Okay, since there is only one element, this is the situation. Now I've called enqueue for the second time, means I've called my insert for the second time. So when I call insert for the second time, that means here the choice I've entered is 1. Like you can see here, so choice that I entered here was 1. So I've entered the choice as 1. When I enter the choice as 1, I go to the switch case, the first case. I go to the first case, okay, and I enter the value here as 78. So I enter the value as 78 and I call the insert function, okay, and I pass the 78 as the value. When I call this function again, so again the first step will be to create a node, and that node will be pointed by this variable new node. Okay, so here this is that step. So already this is existing, so that will remain as it is, and I'm creating one new node. Okay, so now the address of this new node I've just taken as 1200. So again for this new node, this is the data part and this is the next part. Again, a node always has two parts, data part, next part. Okay, now the programming to put the value, I want to put the value, what value? 78 in the data part. So the programming for that is, this is the programming for that. So accessing the data part is done like this: new node arrow data. When I say new node arrow data, I will put the value, whatever value I want to insert there. So the value that I wanted to insert there was 78. So I put here 78. Okay, I'll just highlight you to show what is happening. So using this line here, I put 78 in the data part of the new node that we had just created. Okay, in the previous step. In this previous step, we had created a new node with some memory address. So in that, I insert my value. Okay, so I've done this second step. In the third step, in the next part, I make the value of that next part equal to null. If I go to the next diagram that I have here, so in the next part, this is the next part. In the next part, I make the value equal to null. So the programming for that is this. Okay. Now if you see here, I'm having two nodes with me. Okay, I'm having two nodes with me. I'm having one node at the address 700 and I'm having second node at the address 1200. Okay, so like you told me, in the chat, front should be pointing to the node with the value 20 and rear should be pointing to the node with the value 78. Okay, rear should be pointing to the value with the node 78. And also these two nodes are now two separate nodes. They are not joined to each other. They are not a linked list as of now. So if it has to be a linked list, this first node has to be pointing to the second node. Okay. So now let's join these two nodes to each other and form a linked list. Okay. That is done in my next piece of code. So I join this to the first node to the second node. So if I'm joining the first node, I'm linking the first node to the second node. What should be happening in the null part of the first node? What should happen in the null part of the first node? You can just write in the chat. If I'm linking the two nodes, what value should come in the next part of the first node? This is your first node. So what should come in the next part of your first node?
1200.
It should contain the value 1200 according to the diagram. Correct. It should contain the value 1200. Okay. So we do the programming for it. Now see how the programming is done. Okay. So first I check for this. If front equal to null. Now front will not be equal to null. Why? Because when you check here, front is present here. What is the value of front? Value of front is 700. Okay, it is not equal to null. So that means this thing is false. This thing is false. The if part is false. So we go to the else part. Okay, understood why the if part is false? Because front is not equal to null. So it is false. So I go to the else part. So in the else part, I execute this first line. What I do? I want to replace this value null with the address of the second node. I want to link them. I want to form a link between the first node and a link between the second node. So to form the link, I run this line. So what is that? Rear arrow next means this part. Okay. Rear arrow next. Okay. He gets the value of new node. New node contains the value 1200. Okay. New node contains the value 1200. When I execute this line, what will happen in the diagram is this null that was there here, this null gets replaced with 1200. This null here gets replaced with the value 1200 because of this. Okay. And due to that, since now this next part contains the address of the second node, a link gets formed between the first node and the second node. Okay. So again, for the sake of the diploma students, rear arrow next. Rear. Okay. This is the rear arrow next means this part. Null part. Okay. Gets the value of new node. What is the value of new node? 1200. So that's how here you get 1200. Okay. Since you get 1200 here, it means a link gets formed. So link means this arrow is in diagram form. It is an arrow. So arrow gets formed between the two nodes. So a link gets formed between the two nodes. Okay. Now, like you have told me in the chat here, okay, front should be at 20 and rear should be at 78. So as of now, if you see in this diagram, front and rear are still both at the first node. They are at 20. So now in the next step, our rear should go to the second node because 78 is now our last element. So in this next line of code, I give the value of the second node. What is the value of second node? The address of the second node? 1200, which is contained in this variable new node. So I give that value to rear. So what happens? This rear gets shifted from this node to the second node. Okay, because of this line of code. So new node which was having this value 1200, that value 1200 is given to rear. That means rear starts pointing to the node with the address 1200. So now it is exactly like the way you have told me. Front is pointing to the first element 20, rear is pointing to the last element 78. Okay, remember we are using a singly linked list to implement a queue. Therefore, the last node of a singly linked list, the next part is having the value null. Okay, so when I exit this function, okay, after I have executed this line, I will print this message, insertion is a success. And when I exit this function, what will happen? This variable new node will get deleted because it's a temporary variable. Okay, and then you will have front at the first node, rear at the last node, and these two variables will remain. And then you can continue doing more insertions or deletions. If you insert one more time, suppose you insert one more time, okay, say I'll not show you all the steps now. I think you have understood. What will be the first step? If you are inserting one more time, can you just tell me what will be the first step? You can type in the chat. I'll keep this program open for you. Can you just look at this and type in the chat for what will be the first step you are inserting again? You will create a, I've just highlighted it. What will be the first step? Type. Suppose we are inserting say 90. So what will be the first step? No, no Siddesh. Here, suppose we are inserting the value 90. Okay, so what I will highlighted this step here. What this step will do? Suppose I am inserting for the third time. What will this step do now? I have kept it highlighted. What does that step do? It will create a node. It will allocate memory. Correct. So it will allocate memory. Okay, I'll do it directly here. So say it will allocate one memory like this, some node. Okay, allocate some node, and it will have this value as pointed by the variable new node. Okay, and this will, some address will be present here. Say the address will be 6700. Yeah. So next part is you want to put value here in the data part. So you want to put value in the data part. The code for that is this. So you access this as, now the diploma students. Okay, I'll just tell you this. So when you are accessing now, if you look at this new node, if someone asks you what is the value of new node, this variable here in this here what I have highlighted, the value of new node is 6700. Okay, so that is the value of new node. The value of the pointer that is present will be the memory address. If you want to access the data part, the programming of that is like this: new node arrow data. Whatever pointer is present at a node, arrow data. So that means I will be accessing the data part. If I want to access the next part, okay, then the programming for that will be new node arrow next. Okay, so this is just in brief. You will have to watch the linked list videos to understand it fully. So in the next statement, I'll be inserting my value. Okay, so using this line, so I will insert some value. Say I wanted to insert a value as 90. Okay, this part I will make as null. So you can see here in the next line I make it as null. Okay, so this has been done. Then what is left now? I have to, if you look at this diagram, what is left now? I have to form a link. I have to form a link between this second node, okay, and this third node. So if I want to form a link between the second node and a third node, what should come in the address part of the second node? What should come address part of the second node? The address of the third node. So 6700 should come here. So that is the time a link will form between the second node and the third node. So the link is formed using this code here. If you check for this condition, front will be not be equal to null, because what is the value of front? Value of front is 700. So this will be not true. We will go to the else part. So in the else part, you will execute this line, rear arrow next. So rear arrow next means this part. Rear arrow next means this part here. Okay, this part here. Rear arrow next. So this is that part. Rear arrow next. What I've just made as yellow. So what will happen? I'm storing the value of new node. What is the value of new node? 6700. This is the value of new node. So 6700 will go here because of this line here. So when that 6700 goes here, okay, a link gets formed between the two nodes like this. A link gets formed between the two nodes. Okay, now is it over? Is it over? Once I have formed a link, is my program insert function over, or is anything else left? Look at this diagram and tell me what is left. What is left? What are we forgetting, or is it over? We need to shift rear. Okay, we need to shift rear because rear should be pointing to the last element. Yes, correct. Siddhi Lakshmi and Siddesh, correct. We need to shift rear. So that we do using this line, last line. Okay, last line, this line here. What we do? New node's value, which is 6700, that is given to rear. So when that is done, rear will get transferred from here, or it will get shifted from here and will come to this variable here, or to this node with the address 6700. Okay, so I hope you have got this, how it works. Clear? So like that you can keep inserting. Every time you keep inserting, rear will keep getting shifted one node in advance, like one node forward. So rear, you have to keep moving your rear. Front will remain fixed. Front will remain at the first element. Okay, rear will keep getting shifted. So that is how your NQ operation works in this implementation of queue using linked list. So any doubts here before I show you the DQ operation? I'll keep this function open. Any line that you don't understand, you can just tell me right now. Insert function, any line you're not understanding? I hope you're making notes of the diagrams and all what I'm explaining, and not just, I'm not, some storytelling is not going on. I hope we are taking down your notes. Okay, and before I forget, in your classroom, I've already shared this. If you go to this meeting link, I'll show you later. In the meeting link, I already shared this program with you. Okay, so you can write down this program, and then you need to draw diagrams like this. It's a very important question that you can get for exams. Stepwise, you have to show like this diagrams. You have to show stepwise. A question only comes for 8 marks. Stepwise, show the NQ and DQ operations of queues using linked list, or any of the programs for that matter. So when you're asked to show stepwise, you have to show like this. Okay, here I have written shortcut malloc, but you're not supposed to write shortcut. You'll have to write this whole line there. This entire line you'll have to write there, and then draw the diagram for that line like this. Then write the next line of code, draw the diagram, and so on. You have to show stepwise what happens. And if you show each step properly, then you will get your marks. For your exams, you can just show one NQ and one DQ. You need not show many examples. Here I'm showing you so that you understand everything properly. Okay, so I'm just deleting this other part that was not originally part of this. So NQ operation, is it okay? Okay, I'll move ahead then with the DQ. So now DQ operation, like you know, whenever this is now this is your cube, okay, it's having two values. So whenever you do deletion is always done from the front, okay. So whenever you delete, the first element that had entered will be the first element to be deleted. Therefore your queue is known as a first in first out data structure, first in first out data structure, because of this. Whoever enters first is deleted first. Now 20 will be deleted first. After you delete 20, what will remain in your queue? Only one element, and that element is 78. So what should happen? This 78 will be your first element, also your last element. So what should happen to front? Front should get shifted from this node to this node. Again, I'll just repeat. When you are deleting, deletion always happens from the front. Okay. So when you finish deleting this element 20, okay, only one element will remain in your queue, that is 78. So this 78 will be your first element, also your last element. Because it's your first element, this front should be pointing to 78. Because it is the last element, rest should also be pointing to 78. That is what will happen when we call dequeue. Okay. So here we were inserting 78, so I'll just insert 78 and show you. So I inserted 20 and 78. So when I insert 20 and 78, your menu looks like this. It keeps getting repeated infinitely. Okay, like I told you. Now I just call the display and show you. So when I call display, it will show me the two values in my queue. So the two values in my queue here, you can see 20, 78. And after 2078, I'll just put this. If you want, you can put this. I'm just showing that nothing else exists after 78. Or if you don't want, you can remove this part. Okay, it's not compulsory to show this null part that I've shown here. Okay, so this was your insert. I'll show you the dequeue quickly. Okay. So again, when this menu is displayed, if you want to do delete, you have to enter the choices 2. So when you enter the choices 2, you will call the dequeue function. The dequeue function is in this case is DEL function. So you call the dequeue function. When you call the dequeue function, it will be this function here. Okay. So again, we check if the queue is empty. If the queue was empty, what will be the value of front? Value of front will be equal to null. See here. Initially there was no queue. Okay, we did not have any queue. The value of front was equal to null. We are checking for that here. If the queue is empty, then value of front will be equal to null. But in this case of ours, in this case, what is value of front? Value of front is 700. Okay, address of that node is the value of front. So value of front is 700. Is not equal to null. Not equal to null. So do not execute this. We go to the else part. So in the else part, what we do? We execute this line here. I declare one temporary variable temp. Okay. To that I assign the value of front. Value of front, like I told you, is 700. Value of front is this 700. So assign the value of front, which is 700, to temp. So in your diagram, it will look something like this. Okay. That means temp will start pointing to the node with the address 700 because of this line. Okay. So in your line, it is this line here where value of front you are giving to temp. So value of front you are giving to temp. So I've combined two things here. I've declared this variable. I've declared this variable here of type struct node. At the same time, I've assigned a value of front. So I've combined two steps. Okay. Now, like I told you, when we delete this part, front should be pointing to 78. So before we do this actual deletion of this node, we need to shift front. We need to shift front to 78. So that is done using this line. Front equal to front arrow next. Okay. Now, front arrow next. What is front arrow next value? Front. Front is this. Arrow next. Value of front arrow next is 1200. Okay. Value of this front arrow next is 1200. Again, I'll repeat. Front arrow next. What is the value there? 1200. That value of 1200 we give to front. So that means front will shift from this node, the first node, and go to the second node. Why? Because that node is having the value 1200. Understood how it is getting shifted? For the sake of the diploma students, I am telling it again. So how it happens? So front arrow next value is 1200. Okay. So that 1200 which was there in front arrow next is given to front. So because front is now 1000 having the value 1200, it starts pointing to the node with the address 1200. So it gets shifted from this node to the second node. Okay, that is what happens in this step here. The front gets shifted. Once I've shifted this front, next step is to delete this node. So for deleting that node, I use the inbuilt C function free. So free is an inbuilt function. For that, I give the pointer of this node. So the pointer of this node was temp. So that means free will deallocate the memory pointed by temp. So meaning of this is, so it will look something like this in your diagram. The node gets deleted. The memory is deallocated. Okay. Why it is deallocated? Because I mentioned that temp as the parameter of this function free. So this node will get, memory will get deallocated. So what will remain in your queue will be only one element, 78. And that 78 will be, since it's the first element, it is pointed by front. Since it's the last element, it is pointed by rear. Clear? So this is your code of delete. Just go through it. Any questions, you can just let me know. Any questions, students? Okay, no questions. Then what we'll do, we'll do one delete and we'll see. So now when I call delete, like I have shown you in my Excel, 20 should get deleted. So I want delete, so I'll take the choice as 2, and then it will tell me that I have deleted 20. So let's call the display function and see that 20 has got deleted. I'll call the display. You can see here only one value remains. That value is 78. Okay, only one value remains here, and that value is 78. Clear? So again, this menu gets displayed. Again, I can keep deleting. Okay, let's do one more delete so that you understand this clearly. So now if I delete, okay, you are having just one element. Again, this I'll just ask a question to all of you. If I delete this element, Q will be empty. Okay. If Q is empty, what should be the value of front and rear? You can type in the chat. See, right now we are having one element. If I delete this only element that is present, after deleting, what should be the value of front and rear? Siddhi Lakshmi, if you were doing using arrays, then that would be -1, correct? If you were doing using arrays, but now we are doing linked list, so value of that will be null. Okay, in linked list, value of front and rear will be equal to null. So if it was arrays, then that was correct. So clear? Okay, good that the diploma students are answering. Regular students, are you there? Are you understanding, or it's going? I'm not seeing your responses today. Ashish, Athena, all those people who should reply. Aman, where are you all? Okay. Okay. So let's do one delete function, one more example quickly, and then we'll stop the class because you must be also tired. Okay. So again, suppose I enter the choice again now. So I call this menu function. I enter the choice again as 2. So again, this case 2 is executed. I call this delete. So again, I check here if front is equal to null. Front is not equal to null. Okay. Why front is not equal to null? Can diploma students answer? Why front is not equal to null? What is the value of front? Nikhil? Nikhil? Can you tell me what is the value of front here? From this diagram, what I'm highlighting, what is the value of front? Value of front? No. That is value of data. What you are telling is the value of data. Value of front will be the address of that node. Address of that node is 1200. Okay. This 78 is data part of the node. Value of front is this address. Okay. If I ask you what is front arrow data, then value of front arrow data is 78. If I ask you value of front arrow next, value of that is null. If I ask you value of front, value is 1200. Okay. Please try to remember this. Okay. So I give the value of front to temp. So therefore I will get temp here to this node. Okay. The next step, what I do? I execute the next step. What is the next step? Once I've done this, your diagram will look like this. Temp will also start pointing to this node. Okay. The next step, when I do this, front equal to front arrow next. Okay. Everyone pay attention. Okay. Here, many of you then get confused about this line here. Front. Okay. I'll just try to highlight it here. Front. See this front. Okay. Arrow. This arrow next. What is the value of front arrow next? Null. This null. Okay. Null. So that means here this right hand side part value is null. Here. This right hand side part value is null. Okay. This I just made it red. Whatever this right hand side part, red part is there, that value is equal to null. How are we getting that value null? Here see, front arrow next. What is the value in front arrow next? Null. So this null which is present in the right hand side is given to this variable front. So now what is the value of front if I ask you? After executing this line, value of front will be equal to null. Clear? How value of front will become null? Is it clear to everyone? Okay. Has everyone got it? Okay. So that means now value of front will be equal to null. So in your diagram, what will remain? Rare will remain and temp will remain. Clear? Because value of front is null. Then in the next line, what I do? After I've executed this line has made front equal to null. Okay. I display the value that is going to get deleted. So I display the value 78. And then I free the node pointed by temp. So this node is pointed by temp. So I free it. Then I free it means I deallocate a memory. Free meaning deallocate a memory. When I deallocate a memory, ray will be hanging just like this. Okay? Ray will be hanging just like this. Now as you can see here, our queue is become empty. We do not have any queue with us. So when we did not have any queue with us, if you remember initially, value of front and ray, what should have been the value of front and ray? Value of front and ray should have been equal to null. When we do not have any queue with us, value of front and ray should be equal to null. Okay, that is what, if you remember here, that is what we had said. So now in this case here, after I have deleted this node, front is become null, but ray value is still not null. Ray value is some garbage. Okay, so what I need to do is I need to make ray value equal to null also. Why? Because queue is empty. I do not have any queue with me. So I need to put this code that I have written here. Okay, it's as of now it's not there, but you need to put it here in the else statement. So I'll just put it here. You need to put this: if front is equal to null, then also make ray equal to null. If front is equal to null, then also make ray equal to null. Clear? Understood why this I am adding? So because front is I do not have any queue with me, and just before the queue became empty, what was the value of front? Value of front was null. So I use this part and I put it in the if. I say if front is null, okay, then here make rear also equal to null. So when I execute this line, the front also will be null and rear also will be equal to null. And then that ends our dequeue. So if I run this again, I say choice 2 and 78 gets displayed, and if I run this again, I try to display, nothing will be there. I will get queue is empty because 2 elements were there. I deleted both the elements. Clear? Okay. Any doubts? Okay. If you can see here in the right hand side here in the of my screen, your attendance is getting recorded. Okay. So if you think that I'm not taking attendance and all, please don't think like that. I get the exact timings of when you enter the class and when you leave the class. Okay. So in case, and this gets downloaded to my system when I end the meeting. So if you think that I'm not taking attendance and all, and because of that you're not attending the class and all, then please note. Okay. Okay. So any questions about this, about today's topic?